Right, Sat Shri Akal, students. Today we will derive distance formula. Now students, let's understand how the formula is derived and how we can understand it better. Well, we know very well this is our y and x axis. Hence, this plane is known as xy plane. Now in xy plane, if I want to draw any point, let's say point P, it must have two coordinates, x and y. This is abscissa and this is ordinate. Now, the knowledge of abscissa and ordinate is very important to understand distance formula. Now, students, let us see there is another point Q and its coordinates are x2 and y2, and let us say this is x1, y1, not xy. Let us say this is x1 and y1, the coordinates of point P. Now students, the question is, what is x2? x2 is basically the horizontal distance from y-axis towards x-axis. This is x2. Now, what is x1? x1 is the horizontal distance of the point from y-axis. Similarly, students, what is y2? y2 is the, you can extend this. Students, y2 is the vertical distance from x-axis, right? Similarly, what is y1? y1 is the vertical distance of point P from the x-axis, right? So, having defined x1, y1, x2, y2, if somebody asks, what is the horizontal distance between 2 points? Now, this distance is basically this distance, the horizontal distance between 2 points. What is this distance? So, this is this total distance, which is x1, and this distance, small distance, that is x2. So, total distance is x1 and this distance is x2. So what is this distance? So students, obviously we can say that this distance is x1 minus x2. Similarly, this total distance, you see, this distance is y1, vertical distance, and this distance is y2. So what will be this distance? So this distance is basically vertical distance between 2 points. This is the distance. And this will be y1 minus y2. Right? Now, if I join what? Let's say I join PQ. And this PQ is the distance which I want to calculate using distance formula. I'm interested in finding out how far P is from Q and vice versa. So now you see I'm getting a right angle triangle here, students. How? I'm getting a right angle triangle. And in this right angle triangle, the perpendicular is y1 minus y2 and base QP. Oh, sorry. Let's say this is L. So base is QL and base is x1 minus x2. And what is the perpendicular? Perpendicular is PL, which is equal to y1 minus y2. Now, what is the distance PQ which we want to find out In this right angle triangle, if you see, this PQ distance is the hypotenuse. QL is the base, PL is the perpendicular. Using the Pythagoras theorem, you students, we can use Pythagoras theorem on this right angle triangle, PLQ, which is right angle at point L. So according to Pythagoras theorem, we know that hypotenuse square is equal to base square plus perpendicular square. So using this, students, hypotenuse square is equal to what is base? Base is x1 minus x2 whole square plus what is perpendicular? y1 minus y2 whole square. So obviously what will be h? It will be plus minus under root x1 minus x2 whole square plus y1 minus y2 whole square. But we will not take minus sign, phi, students, because distance we will take as positive. Distance between 2 points we will take as positive. So h will be equal to, we will not take minus sign. Now students, just see, what is x1 minus x2? x1 is the abscissa of point P, x2 being abscissa of point Q. So x1 minus x2 can be considered as difference between abscissa of 2 points. Square of this plus, similarly, what is y1 and y2? y1 is this distance, vertical distance or the ordinate of point P, y2 is the ordinate of Q. So we can say length of, please mute yourself students, difference of ordinates whole square and a root of that. This, students, this is known as distance formula, and h, hypotenuse, is actually PQ. Now based upon this, let us say this is one point P which is having uh, 2 and 5. Let's say its uh, coordinates are 2, 5. Let's say point Q coordinates are, let's say it is 4 and 8. Let us say, right? So based upon this formula, how we can find distance between PQ? So as per the distance formula, PQ is equal to x1 minus x2 whole square plus y1 minus y2 whole square, root of this. So what is x1? We may consider this as first point, this as second point. But students, you can go reverse also. You can consider this as first point, this as second point. We will see the answer will be same because ultimately it will be square. So x1 minus x2 would be 2 minus 4 whole square plus what is y1? 5. What is y2? 8. So it is 5 minus 8 whole square under root of that. So this is equal to minus 2 square and this is minus 3 square under root of that. So this is 2 2s are 4, 3 3s are 9, that is equal to root 30. Students, if you go as the formula is written in the books, that x2 minus x1 square plus y2 minus y1 square, the answer you can see would be same, root 13. Now let's see, students, quickly, if this is x and y axis and this point is P. Let's say the coordinates of P are x and y, and we want to find out the distance of this point from the origin. Now we know coordinates of origins are 0 and 0. So again applying the same formula, distance PO would be equal to under root difference of the abscissa. Difference of abscissa is x minus 0 whole square. And what is the difference of coordinates? It is y minus 0 whole square. So you see students, here I am doing, actually I'm subtracting the coordinates of first from the second. So it doesn't matter, answer will be same. So it is equal to x square plus y square under root. So students, you see that the distance of any point from the origin is x square plus y square, right? It doesn't really matter whether the point is in second, third, or fourth quadrant. The distance formula would be same. We can extend the concept of distance formula to find the distance of a point on a line which is parallel to x-axis and a line which is parallel to y-axis. Now, you see students, this distance, you know, distance of a point, this is a line L which is parallel to x-axis. So, suppose we want to find the distance between these two lines, shortest distance between these two lines. So you will have to take these 2 points and you can apply the same formula and find out the shortest distance between 2 points. Similarly, students, you can define 2 points here and find the shortest distance between these two lines also. So this is all about distance formula. Thank you very much.